Let us know about types of functions. Let us study what is an injective function. A function f defined from set x to set y is injective or 1 if the images of distinct elements of set x under the function f are distinct. That is, if x1 comma x2 belongs to set x and if fx1 equals fx2, then x1 equals x2. Otherwise, f is called many one. Let us have some basic examples. In this function, f, 2 and 4 have the same images, hence it is a non-injective or a many-one function. In this function, f all have different images, hence it is an injective or a 1-1 function. In this function f, 1 and 3 have the same images, hence it is a non-injective or a many-one function. In this function f, all have different images, hence it is an injective or a 1-1 function. The next type is surjective or onto. A function f defined from set x to set y is surjective or onto if every element of y is the image of some element of x under the function f, that is, for every y belongs to set y, there exists an element x in set x such that fx is equal to y. Let us have some basic examples. In this function, all elements of set y are not connected, hence it is not a surjective function. Similarly, in this function, element d of set y is not connected, hence this is not a surjective function. Whereas in this function, all elements of set y are connected, hence this is a surjective or an onto function. Similarly, this function will also be a surjective function. Let us have a remark over onto function. A function f defined from set x to set y is onto if and only if range of f is equal to y. The next type is bijective or 1-1 and onto. A function f defined from set x to set y is bijective if f is both 1-1 and onto. Let us have some examples. In this function, 1 and 2 have same images, so this is not a 1-1 function. Also, element c is not connected to any element of set x, hence not an onto function. So, this is not a bijective function. But in this function, f is 1-1 as well as onto. Hence, this function is an injective and surjective or a bijective function. Let us have an example over types of functions. Show that the function f from n to n given by fx is equal to 2x is 1 1 but not onto. Let us have the solution. The function f is 1 1 for fx1 is equal to fx2. This implies 2x1 equals 2x2. This implies x1 equals x2. Further, f is not onto as for 1 belonging to n, there does not exist any x in n such that fx is equal to 2x is equal to 1. Let us have another example. Show that the function f defined from n to n given by f1 is equal to f2 is equal to 1 and fx is equal to x minus 1 for every x greater than 2 is onto but not 1 1. Let us have the solution. F is not 1 1 as f1 is equal to f2 is equal to 1, but f is onto as given any y belonging to n, y is not equal to 1. We can choose x as y plus 1 such that f of y plus 1 equals y plus 1 minus 1 equals y. Also, for 1 belonging to n, we have f1 is equal to 1. Let us have another example. Show that the function f from R to R defined as fx is equal to x square is neither 1 1 nor onto. Let us have the solution. Since f of minus 1 equals 1 equals f of 1, f is not 1 1. Also, the element minus 2 in the codomain R is not image of any element x in the domain R. Therefore, f is not onto.